We are in section 1.7. Now we're actually not going to follow your book because your book is something you've already done. You've done rotations, reflections, translations. Those are all transformations. But we're going to do an extension. Now let's go over a little bit of review. You should know that a rigid motion is a transformation that preserves the distance and angle measure. So let's write that down. That's important. Even if you've heard that before, it's something to note. So let's read that again. A rigid motion is a transformation that preserves distance and angle measures. Now, in a transformation, the original figure is always called the pre-image. The resulting figure is always called the image. Alright, this graph you do not need to draw, but we're going to quickly review what a reflection is. As you already know, a reflection is when you have a mirrored image of something. So I'm going to draw a reflection in red. Now, the vertical axis is Y, and the x-axis is your horizontal axis. So if I would reflect this trapezoid over the y-axis, you would get a shape that looks like this. Notice that it went over the y-axis. If I said reflect the blue image over the x-axis, it would have gone up and look something like this. Now, if you would have moved it to either one of these, for example, this would be A prime, B prime, C prime, D prime, and so on. So this one right here, this is called the pre-image, this is called the image. They preserve distance and angle measures. So this is stuff, that's review. None of this is new stuff for you. So let's introduce an extension to this. Let's make it harder. Alright, this entire thing is your key concept on reflecting something across the line. Now, in the past, your reflections have been vertical or horizontal. Now our lines of reflection do not have to be either. So before you write any of this bottom stuff down, I just want you to look at this picture. The dotted line represents your line of reflection. So line M here is your line of reflection. So let's read this. A reflection across line M, called the line of reflection, is a transformation with the following properties. So here are our properties. If A is on line M, which if we look, A is right here on the line, then that image of A is itself. That means this. A and A prime are going to be the same point. If a point B is not on line M, then M is the perpendicular bisector of segment B prime. So we're going to draw this. So I'm going to turn my iPad, so if it doesn't look exactly the same, that's okay, because it's hard for me to draw this with a stylus. So if I reflect this blue triangle, ABC, it would look something like this. So I did the best I can there. Now A is going to become A prime, B is going to become B prime, and C becomes C prime. I reflected it over line M. Now, here's where the tricky part comes into play, this last piece. If point B is not on line M and point B is not on the line, then M, line M, is the perpendicular bisector of B to B prime. So I'm going to draw this. If you would actually connect B and B prime, notice this. This is the important part. BB prime and line M are a perpendicular bisector. Perpendicular bisector is the red line is bisected. Line M is the bisector. Here's what it does. This red dotted line, notice there's a right angle here. So this piece here and this piece here are congruent. and I'm going to put this in green, so maybe you can see it better in green. I'm going to put a tick mark here and a tick mark here. Hopefully you can see that this segment here and this segment here are congruent. They're equal. That's why line M is the perpendicular bisector of BB prime. It's the same thing is true with C. If I drew a segment from C to C prime, the line M would split it in half. So any point that is not on this dotted line is going to be, that dotted line is going to be the perpendicular bisector if you connect the reflected points. So we're going to do example 1 together. Reflect triangle FGH over x equals 3. Now first off, I'm going to show you correct notation. This is what it would look like. Reflection, and then you're going to have x equals 3 of triangle FGH. So if you see a capital R, that means reflection. If you see this, it means what you're reflecting over. It could say y-axis, x-axis, or anything other than x and y-axis. It could be an equation. It could be y equals x plus 1. And then here is what you are reflecting. So the first thing I'm going to do is draw a graph. And poof, here's my magic graph that comes on the screen right away. All right, you obviously don't have to draw on graph paper right now in your notes. That's fine. You can make a rough sketch in your notebook. So the first thing I'm going to do is, in blue, draw my original shape. So -2, -1, we always label. That'd be F. G is 2, 2. And H is 4, -3. Now I'm going to magically connect them all. And magically my blue triangle appears. In red, I am now going to draw my reflection, x equals 3. X equals 3, I'm going to draw on a dotted line. This is your line of reflection. So I'm going to reflect over x equals 3. So that means it's going to flip horizontally over the over x equals 3. So I'm going to do my image in green. So let's start with F. Here's where it gets a little tricky, but if you remember what you're doing, it's not hard. Remember, you're preserving distance. So F is 1, 2, 3, 4, 5 units away from the line of reflection. So we're going to go the other way. 1, 2, 3, 4, 5. So we're going to call this F prime. G is going to be 1 to the right since it's 1 to the left. And H is going to go to the left 1 space, and that's going to be H prime. And I magically connected my green triangle, and you just drew the image of the pre-image triangle FGH, which has been reflected over x equals 3. Example number 2. The coordinates of vertices triangle FGH are these 3 points. Graph triangle FGH and the reflection over the line y equals x minus 3 of triangle FGH. So the first thing I'm going to do is magically have a coordinate plane appear. And there it is. So now we're going to first just graph the points we have. So let's graph F, which is 2, -1. And then we're going to graph G, which is -2, -1. And then we're going to graph H, which is 3, 4. So I'm going to connect these. That was a really bad line. There we go. Now, using red, I'm going to graph our line of reflection. So remember, this is review from last year. Graph the line however you like. I always like using slope-intercept when it's in slope-intercept form. So I know it crosses the y-axis at -3. My slope is 1, so I'm going to go up 1, right 1. So my line of reflection, I'm going to always do dotted. Looks like that. So I'm now, what I like to do is tilt my paper or tilt my iPad and look at the line of reflection and pretend it's vertical. So you have to take this blue triangle and reflect it over that line of reflection. So F, I always start with F or whatever line's touching a point. F prime is the same point. It doesn't move. So now I'm going to go and look at G. G, I'm going to go straight across. So 1, 2, 3, 4, 1, 2, 3, 4. It's actually a little, I'm going to move this up a little bit. It's going to be a little bit farther down here. I kind of ran out of graph paper. So 1, 2, 3, 4. And this is going to be G prime. Now, well, I'll get to that in a second. So then I'm going to look up here at H, go straight across. So it's going to be right here. And then we're going to call that H prime. And there is my reflected triangle. And this triangle is triangle F prime, G prime, H prime. Now, this is the key concept that you have to be really keen on knowing. So I'm going to draw, let's do like orange. Now you don't have to draw this, but I want to draw this invisible line here. Notice that these 2 points, or these 2 lines that I'm connecting, they don't exist. That's why they're dotted. But remember what we said, it preserves distance. That means that this piece here, let's use purple. This piece here and this piece are congruent, and this piece are congruent. So this line, remember what we said, this line here is a perpendicular bisector of H prime and G prime. This imaginary segment here is congruent to this. This piece is congruent to that. That's important to note when you are reflecting. So there's reflection. All right, and if we aren't having fun yet, let's get the party started because this is going to be a lot more fun. Rotation. You all know rotating is like spinning something. You've done rotation, but you probably haven't done it to this extent. So let's start with our first properties here. A rotation of x degrees about point Q, called the center of rotation, is a transformation with these 2 properties. The image Q is itself, that is Q prime equals Q. For every other point, V, and that could be any other letter, QV prime is equal to QV, and the measure of angle VQV prime is equal to X. Now you're like, what in the world are we talking about? All right, so here's your picture. Now, if you don't want to draw it yet, you don't have to. If you just want to listen, that's fine. This is my original shape. So this is my pre-image. This is my image. This has been rotated up. And I know they might not look congruent. They should be, but it's hard to do on an iPad. This shape here and this shape here are exactly the same. It's been slid up. This first statement says that since we're moving something about point Q, Q and Q prime are the same point. So that means the image Q is itself. For any other point, V, so in this case we're looking at V, that means QV prime is equal to QV. That's important. I have white tick marks here. The distance from Q to V and the distance from Q to V prime are the same. When you do this on Monday, you're going to have to take a ruler once you use a protractor, and you're going to have to measure this distance here, and the same distance has to be measured here. Your rays have to be exactly the same distances. So actually, they're going to be segments. Then it says the measure of angle VQV prime, that's this angle here, that's going to be X. And that X right here, this is called your angle of rotation. So if I said you are going to move an image or a pre-image and rotate it about point Q 30 degrees counterclockwise, you could go up. That means this right here would be 30 degrees. And it'd slide up. If I said, so counterclockwise is this way. If I said clockwise, it'd go down. So this is rotation. You are going to have to measure this angular rotation. Now, I am not going to go over an example of this right now because it's hard for me to do it on an iPad, especially when we're using a protractor. So on Monday, you need to bring graph paper. We're going to use our protractors to actually measure these out, and we will do a few of them together before I let you get started.